Hello everyone and welcome back. Today we're going to continue on our discussion of the variables, expressions, and programs. And today we will talk about the statements and parsing expressions and the concept of the overloading. So as usual, feel free to follow along with us either in the video or in your own slides. So we have this idea of compound expressions. A compound expression may involve expressions of different types. When the expression is evaluated to its value, like we saw last time, the type of the value will depend on the types in the expression. The expressions are then going to be parsed using the order of operations. So some examples of checking the type of compound expressions with Python can be seen here. We could do type of the expression 3 plus 4 and get int, type of 4 minus 2.6. Oh, it's mixed, but I'm going to need to convert this to a decimal and then do the subtraction. That will be type float. And here we have 2 less than 3. This is going to return either true or false. So that one will be a Boolean. We have statements and this idea of parsing the expressions. A statement is an instruction to perform some actions. When Python executes the statement, it performs the corresponding action. Observable change by actions are called effects. Like, for example, taking input from the keyboard, printing text to the screen, drawing a picture with turtles on the canvas, which you'll practice with in a few weeks, saving data to a file, and many other things. The central role of statements is what makes Python be an imperative programming language. We also have this idea of the pass statement. There's a statement which causes no effects. It doesn't do anything. So you might think, well, that seems silly. Why would you have something that doesn't do anything? That's very useful as a placeholder. And so we haven't done functions yet, but you can see this idea that maybe we would want to create a function and then we don't know what's going to go in there. So we'd put pass there, like I'm going to get to it. And so it allows Python to not make an error, but to pass on to the next statement. So we'll have this idea of parsing the expressions. When Python parses an expression, it attempts to extract the meaning from the code that's provided by you, the coder. It then interfaces between the code written by the humans and the computer hardware. When the code does not work, it is often because the meaning as parsed by Python does not match the intended meaning of the coder. This often happens when you run something and you don't get an error. So here's an example of printing hello, right? So they almost certainly meant to put the parentheses and the quotes around this to print the word hello. But of course, Python doesn't know that that's the meaning. We look at this and we say, oh yeah, I know what they're supposed to do. But it also happens that sometimes you forget to do this, or your code is working because it doesn't make an error in that sense, but the answer that it gives is something that is unexpected. And so usually when that happens, it's almost certainly that there is a problem with the parsing. So here's a couple of examples. You can write the expressions in words and then parse the expressions and evaluate and then give the types as a quick review of some of the things we talked about last time. You can go ahead and pause this video if you'd like to try this out, and we look forward to seeing you in a few minutes. Hello, welcome back. So here we're going to take a look at these expressions. We can express this one as 16 divided by 7, the remainder of that. The mantissa would be another way to say this. This is going to be the result of 3 to the power of 2 evenly divisible by 4. However much this is going to be, and C will be 22 divided by 7. We also asked you about the various types and to actually evaluate the expressions. So here we have A, it's going to be 16% 7, which is going to give you 2, which is an integer. Remember that the remainder given by the mantissa will always be integer. Floor division similarly will also always give you an integer, and then we're going to raise that to the power. So here we're going to apply order of operations. Exponents takes precedence over division. So we would square 3 to get 9, and then we'll apply floor division with 4. So 4 goes into 9 evenly 2 times. And so we see that the answer will be 2. That's an integer. And here we have 22/7, which is pi. And this will be equal to 3.14, which is a type float. We also have this idea in Python of the overloading. So what is that? Overloading occurs when we have a symbol, such as a math symbol like plus, that can be used for various types. So probably thinking about 2 plus 2 is pretty reasonable, and you could also do 2.0 plus 2.0, and you probably don't think much about it being a different operator because it's still plussing, but there is some mechanistic difference in how one would solve it, and that becomes even more pronounced when we think about concatenation, which is joining strings together. Clearly, joining strings together is not the same thing as solving 2 plus 2. And so this gives us the idea of overloading. That is, we're going to reuse an operator to act on various types. So the operator plus, for example, is overloaded to work on a variety of types. Overloading occurs when different but conceptually related operations are given the same notation. It's just for our convenience because the way in which they actually work is different. That means there's separate Python code in order to do these things. The types are what tell them apart. Python looks to see what is the type of the input, and then it decides what operation it should do. Should it do concatenation to bring strings together for plussing, or should it be doing addition of 2 plus 2? An expression gets more complicated as it becomes increasingly important to keep track of their types. So let's take a deeper look at this. The plus symbol is used to evoke the concept of adding things together. Adding is mechanistically carried out differently for the different types. It means that each type has its own code to do the adding. However, by convenience, each accomplishes a related task for each of the types. Here we see that integers can add together. So we have integer addition. We have floating point addition for 2.0 plus 3.0. We have concatenation. This is joining 2 strings together, done another way. And then we also have 4 plus 2, but they're in the quotes. So they are not considered numeric. These are the characters of 4 plus 2. So Python will carry out concatenation. Here's some more examples showing overloading. Here's overloading of plus with strings. So we have some variables A, B, C, and some values for them. So we're going to have H plus the variable A, which is equal to AVE. You can probably already see what my message is for you. And then we will add B and C and concatenate all this together, and we get the have a great day greeting. So there are 3 distinct uses of plus, that is adding integers, adding floats, and carrying out the concatenation. There's also overloading applied to the star operator. Remember, this is for multiplication. Multiplication is overloaded for integer multiplication and float multiplication. It is also defined for strings. It performs repetition. So for example, if b is equal to hop, and we have 3 times b, we'll get hop, hop, hop. Here's a little code for you to take a look at and debug. So when you see the bugs showing up like this in the corner, this indicates that something might be wrong with the code. So we have this problem here where we have some code. It's explaining what it is. We're basically, the idea is here is we're going to calculate the volume of a room based on the number of tiles of a known size. So if you know how big the tiles are, they're 3 by 5, we could estimate the size of the room by simply counting up the tiles and multiplying together the dimensions times the number of tiles. So if the floor is 7 tiles by 8 tiles, and they're 3 by 5. Let's say those units are inches. Then we would multiply 7 times 3 and then 5 times 8 to get the overall dimensions, right? Okay, so this program claims to do that. Tx, number of tiles in the x direction, is 3. Ty is equal to 5. Then we try to compute the length of the floor. Why don't you take a moment to see if you can spot what might be wrong? We'll see you back in a few minutes. All right, let's take a look at this debugging here. The problem had to do with this line right here. Did you catch that? In the original one, the 8 times ty was in the string. So what happens when you run this code is you'll have 7 times tx, which is 3, 21, y equals 8 star ty, which is going to remain a string. So y is a string and x is the integer 21. So what will you get? You'll get repetition 21 times of this expression here, which is not what we had in mind. So the way to correct this is to actually do the multiplication by removing them. I also took the parentheses off of this one because they were unnecessary. It wasn't really something that was wrong with it, but I did just clarify so that they're all the same. And then we'll print out the volume and we get a much more reasonable answer. All right, well then that concludes our discussion of the variables for today. I hope you found this helpful and learned some things about the overloading and working with the various types in Python. We will see you again next time.